Okay, guys. We actually solved equations around the first week of school before I had my handy dandy little recorder thing. So I'm just going to give you a real quick recap of what we've been doing. That way, if you do need some extra help, then you can just watch this video. First off, we started like the first week of school talking about how would I simplify this. And y'all would tell me that we distribute. That's the fancy word. And this is just a recap. That would give us 5h, because remember there's an understood 1, plus 10, because to each term. Then when you distribute this one, make sure you do negative 3 times h, which is negative 3h. Negative 3 times negative 6 is positive 18. This always kind of tricks people, but remember that behind the negative sign there's an understood 1. So negative 1 times 2h is negative 2h. Negative 1 times 7 is negative 7. And then after we do that, we combine like terms. And remember, when you're combining like terms, you're not moving anything over to a different side of the equation. So you're just keeping the same signs. So here are our like terms. We have these, and then I'll highlight it to show you. And then we have these numbers. And those are our like terms. Okay, so 5 minus 3 is 2. Minus 2 is 0h. Interesting. We don't have to write 0h. And then we have 10 plus 18, which is 28, minus 7 is 21. So that's the final answer. Well, not really answer, because this is what it simplifies to. It's not really an answer. Not normally, but sometimes your variables will not cancel out. It just so happens that for this example that I created, they did cancel out. The first equation, well, not the first equation. This was the steps that I reminded you of. Remember, you don't have to do these steps. This is just a suggestion. The first thing you really want to do, though, is you want to distribute. That's the stuff in your parentheses. Then we talked about combine like terms on each side. That's our fancy words. And then solve. And in order to solve, we get variables on one side, numbers on the other. And remember, I like to move over the smallest x, but that does not mean that you have to. Here was some baby examples. Some of it started from the 7th grade, which most of you should already know. And in class, we didn't even really go over these because y'all did remember it. In fact, where we started at in class was problems like number 4. So I'm going to go ahead and do that one. Remember, the first step is to distribute, so that would basically be 6x minus 18 equals 4x minus 4, because you distribute to each term. And then I like to move over the smallest x, so instead of having 4 here, I'm going to move it over by doing the opposite operation, which is to subtract it. So I'm going to have 2x minus 18, that canceled, equals negative 4. Then I'm going to go ahead and add 18 to each side. And I'm going to get 2x equals 14. Then divide by 2, so x would equal 7. All right, moving down to problems like number 5, who I love. So for this problem, for number 5, once again, we're going to go ahead and we're going to distribute. So negative 6x minus 12 minus 5 equals 16. Then I like to do combine like terms. And if you had me last year, we always tried distribute, combine like terms, solve, all right? So for this one, my like terms are basically anything that I can combine on the left side of the equation or anything on the right. Well, there's nothing besides a 16, so I don't have any like terms on this side of the equation with a 16. Here, my like terms is a negative 12 and a negative 5. So I can go ahead and combine them. Now, one common mistake that students make when they combine like terms is they change the sign. They say plus 5, plus 5. Gross. That is not correct. What you do is you just keep the same signs, okay? Just like we say in class, same side, same sign. So we're going to have negative 6x minus 17 equals 16. And then from there, we know how to solve this. What do we do first? We add 17. When we add 17, we're going to get 33. And this is definitely a Ms. Frugier problem because it ends in a fraction. I love the fraction answers. Okay? So we're going to get x equals 33 over negative 6. Whenever we did Khan Academy practice problems, we noticed that you don't have to have the negative on the bottom. And that was last year, if you remember. We can also say that this is the same as negative 33 over 6. Same thing. which also means if I wanted to put it in the middle. So this negative doesn't mean that this is a positive over a negative, just means it's a negative number, a negative fraction. Okay? Let's see. Then if we do problems like number 6, we're going to have the same thing. We're going to say distribute. So I would have negative 2x plus 2 plus 3x equals 7. Combine like terms. Negative 2 and 3 give me 1x plus 2 equals 7. Go ahead and move it over. So 1x equals 5. And honestly, did I even really need to write that 1x? No, I didn't, because that's understood. So your final answer is just x equals 5. But if you really wanted to, you could divide both by 1 and still get the same thing. But you don't have to do that. Okay? Moving on. And I know if this does seem kind of fast, just pause the video, and that way you can work some of these problems by yourself. Okay, one more, yo. You know, because that's how Ms. Frugier likes to talk in class. For this example right here, we're going to do the same thing, but I'm actually going to work this problem twice. The first way I'm going to work it how we normally do in class, and then the second way I'm going to show you another way, especially that the EOC sometimes likes to work it as. And if we look right here, we would have 4x minus 8 plus 3 equals 2x plus 6 minus 7. All I did was distribute. Then from there, I'm going to combine like terms. I notice I have a negative 8 and a positive 3. And on this side, I have a positive 6 and a negative 7. And when I combine them, I'm going to have 4x minus 5 equals 2x minus 1. Oop, funny looking 1. Now I can go ahead. I like to move over the smallest x, but does that mean that you have to? Absolutely not. If you want to move over minus 4x to both sides, you can. If you don't even like moving over the x's first, you can move over a constant. So whatever you want to do. I personally think it's easier to move over the smallest x just because students tend to make less mathematical mistakes by doing so. So right here I'm going to subtract 2x, but remember you don't have to do that. 4 minus 2 is 2x minus 5, which equals negative 1. Then you add 5 to both sides, divide by 2, and you're going to get 2. And remember, this just means that if I subbed in 2 for x, I'm going to get the same answer on each side. That's what your answer would be. Now that's our first way to do it. Now I'm going to show you another way that you could do it with the EOC. Now normally in class we talked about distributing. You have to distribute first, which is a great practice to do. But technically, you don't have to. In fact, if you wanted to, you could decide to move over 3 to this side of the equation first, or the 7 to this side. What you absolutely cannot do, though, mathematically, is move over a term that's in this parentheses without distributing this. Because technically, remember, this is not just x minus 2. This is technically 4x minus 8. So if I did just move over a 2, then I have the whole problem wrong. Because you have to distribute this problem before you move it. Alright, so we're going to go ahead and I'm going to show you the EOC way. And they would pick any number, really. But what they're actually going to do on the EOC, they're going to move this number over, but they're not going to do minus 3 in the computer. What they're going to do is they're going to have the next step listed like this. And that would have been minus 10. Okay? And then from there, they're going to go ahead and distribute. And once again, if we're thinking like the EOC, they would write it this way. Now, they may or may not decide to combine like terms. That just keeps it easy for us. What they could do is they could actually move over this 8 if they wanted to either number. But honestly, please combine like terms. That just makes life so much easier. So my like terms would actually give me negative 4. Once again, on the EOC, they might decide they don't want to move over the smallest x. They might say, we're going to move over the largest x. And they're not going to tell you what they did exactly. All they're going to show you is this. And you can tell that they moved over the largest x because you're left with negative 2 in the end. And then from there, if we go ahead, we would move over our 4. We would add 4. once again, the EOC is not going to put plus 4 in the problem. What they're going to have is they're just going to say negative 4 equals negative 2x. Then they would divide both by negative 2, and you would get a positive 2 in the end. All right? Just knowing the different ways that you can work this problem. But if you wanted to distribute and then combine like terms, then move over your smallest x, that's perfect. You can do that. Because some of our friends, especially that need those steps, they need those procedures. There's nothing wrong with that. But just know that you don't have to follow those steps. You can do anything. You can move it anyway. Just make sure you get the same answer. So my challenge to you would be, why don't you pause the video and then, work this problem again a different way than what I did my previous 2 ways and see if you get the same answer. As long as you get the same answer, then you did it correctly. Okay. Now, if you did pause the video, or even if you didn't, I'm moving on. I gave this problem in class, and I said that 2 students solved the following problem. And I gave this problem. And those 2 students were Josie and Ben. And this is typical of what you would actually see on the EOC, because once again, notice they didn't show you what they did. They didn't have the plus or the minus the numbers. They didn't have the little bitty distributing marks. They just give you the problem. Now what I want you to do is if you were in class, you would have discussed with your partner which student is correct, and for both students, which steps did they do correctly, and then which steps did they do incorrectly. Maybe they're both correct. Maybe only one of them's correct. Maybe they're neither correct. So go ahead, pause the video, figure out who you think is correct, who you think is not correct. All right, I'm assuming that you paused the video and now you're pressing play to go ahead and begin. Who did you think was correct? If you said neither of them were correct, that is the right answer. And you could do that. What I would probably do is I would probably work this problem for myself and then see the final answer. And then from there, I would compare my answers to theirs. Now let's look at Josie first, though. Let's see what Josie did first. Josie must have moved over the 3 first. Do y'all see that? Because she somehow in her first step gets the negative 4 right here. So that means she minus 3. So that was good. Josie did that correctly. Okay? Then Josie looks like she distributed. That was right. Then it looks like Josie moved over her negative 5x, and she got negative 3x minus 4. Josie's mistake came, and I hope you can see it, but Josie's mistake came from a typical mistake that me as an algebra, or not me, but that I as an algebra teacher see a lot. When you go to rewrite, a lot of students forget to bring down this negative sign. That's where Josie's mistake was. And if she would have worked the problem correctly, if she would have had that negative 20, she would have gotten the answer right. Okay, let's go ahead and look at Ben's problem. Ben looked like he distributed first, but did he even do anything with this 3? Doesn't look like it. Looks like he went straight to just writing the problem. So that is where Ben went wrong. But let's see if he did anything else correct. From there, he did move over the 20, gave him that. Then he moved over the 2, gave him that, so that was right. So the only thing Ben forgot to do was to include that plus 3 in the problem. So anyways, learn from Josie and Ben and don't make their same mistakes. All right. The next thing we talked about was special cases. And the special cases you learned in 8th grade. Remember, one answer is either all real numbers or no solution. That's whenever your variables cancel. So I gave these 2 examples just to make it simple. And if you notice, when we go to combine like terms, that would give me 0x. And anytime you have 0x in your problem, that means your final answer is either going to be all real numbers or no solution. So here, I would have 3 equals 3. Well, that means this would be all real numbers because they are the same. But let's talk about why really quick. It's because if I picked any real number, I could pick the number 1, 2, 100, 1,000, 1,000,000. If I plug them in for my x's, I would always get 3 equals 3. Always. I would always have the same answer equal to the same answer. So this means any number in the entire world, if I plug it in, will give me a true equation. Unlike this one, when these cancel, notice you'd be left with 4 equals negative 9. That means that is no solution. So there's no numbers in the entire world that you could plug in that would ever make this be true. Because here, in the first example, 3 is always 3. But 4 is never equal to negative 9. Okay? All right. And then we did fractions as our friends. And the fraction problems really come from 8th grade. All right, but we're going to go ahead and do it. And if you remember what I told you to do, always check to see if you have to distribute. You don't. I like to make common denominators, and then that way I cancel it out. So this would be the same as 2 over 1 and 5 over 1. What's the common denominator between 3 and 4 and 1? 12. So I'm going to go ahead and make each of these equal 12. So 3 times 4 is 12. So what I do to the bottom, I do to the top. Multiply these both by 12. What I do to the bottom, do to the top. 4 times what is 12? 3. Do to the bottom, do to the top. And this is times 12 times 12. Then I'm just going to go ahead and rewrite my problem. So I'd have 4x over 12 plus 24 over 12 equals 9x over 12 minus 60 over 12. And then for this problem, we can easily see that they're all over 12. And so in class, we had a fun little saying. We said bye. And this right here would cancel. All your 12s. And all you really have to look at, guys, is just the top. And from there, we can easily solve these equations. It makes a complicated fraction problem look 1,000 times easier. And then now we're going to subtract 4x. I like to move over the smallest. Remember, you don't have to, but I just like to do that. Then I could add 60. And once again, this is a typical Ms. Fruget problem because my examples almost always end in fractions because I make up the problems off of the top of my head. So 84 over 5. Okay? All right. Let's do the next one. There's nothing to distribute, so I'm going to go ahead and I'm going to find my common denominator. And the common denominator between 2, 5, 10, and 3 would be 30. Okay? So, since it is 30, that would be times 15. This would be times, my brain, times 6. This would be times 3. And this would be times 10. Once again, you're going to go ahead and you're going to multiply your tops. Okay, so 15 times negative 7 would be negative 105 a over 30 minus 24 over 30 equals 15a over 30 plus 20 over 30. Once again, these can cancel. And we can move over our smallest a, which would technically be my negative 105a. But if you're like, Ms. Fruget, I'd rather move over 15a, whatever, float your boat. But if I did move over my negative 105a, then I would have 105 plus 15, which would give me 120. So 120a plus 20. Then I'm going to subtract 20. Negative 44 equals 120a. Divide by 120. And if you want, you can go ahead and you can simplify, and those can both be divided by 4, and that would leave you with negative 11 over 30. But that's not really necessary. It's whatever you want to do. Okay, let's look at our last two examples. I'm going to go through these pretty quick. In class, we talked about there's two ways you can do it. You can either say, view this as this whole problem is over 2. That would be times 2. That'd be times 2, right, in order to cancel it out. And the reason why you're doing that for opposite operations, but also because it gives you the same denominator and it cancels the whole thing. The other way we talked about it in class, because in college they do like you to be able to know this skill. This right here does not just mean w plus 5 all over 2. This also means w over 2 plus 5 over 2 equals 10. So it's however you want to look at it. And this would be the same as 10 over 1. And if you wanted, you could do our fraction rule again. But once again, you don't have to do it this way. It's whatever you want to do. So w plus 5 equals 20. subtract 5, you get 15. And just like I said, if from here you wanted to say times 2, and then have that cancel, you would still have w plus 5 equals 20. All right, and then the same thing for this one. Sometimes they'd say subtract the 3 and then multiply by the multiplicative inverse. You know what? You don't even have to do that. If you want, you can go ahead once again. You can find a common denominator, which would be 3. And I would have 9, because that's going to cancel, right? Minus 2m equals 30. And then from there, you would just solve. You could subtract 9, which is going to give you 21. And then you divide. So 21 over negative 2, or negative 21 over 2, which is the same as negative fraction. It's whatever you want to do. All right, let me look at my very last. This one, if you want to try it by yourself, you can. You can pause the video. It's just for extra practice. Your final, or not your final, but your common denominator should be 15. So it's up to you if you want to try that one or not. And the last thing that we talked about, moving straight along, for solving equations, we looked at solving for variables whenever there's more than one variable in the problem. And these were kind of simple. They came from your book. Last year we actually did more complicated problems towards the end of the year when we had time after LEAP. We kind of dug into them. So students this year found this very easy because it was just review. But if you highlight, because that's what I told them to do, highlight, and we're going to isolate again. Who would have to move? The friend moves first, right? So that means I'm going to add 5. Now, these are not like terms. You cannot combine them. So this would be the same as saying 4b equals negative t plus 5. Then what would you do to get b by itself? Divide by 4. So this is your final answer. Once again, I want you to keep in mind that in college, they could say this is your answer, or they could say that this is your answer. Either way means the same thing. All right? Let's skip on down to, let's not skip on down. We'll go ahead and we'll look at the second example. If I wanted to highlight for y, I'd notice that I have 2 y's. So that means you got to combine like terms first. So I could just move over my 3y. Or you could move over your 4y, your negative 4, that's smaller, but trying to liven things up. Make sure when you write z's, you put the lines through it. That's just a good practice, especially for college. Professors love to see that. And you still want y by itself. So who has to leave? am. So I'm going to minus am minus am. And I get z minus am equals negative 7y. Then divide by negative 7. So y equals z minus am over negative 7. And that's your final answer. I have some other ones for you to try. This problem is going to work the same way as this one if you want to try it. This one, we could break it apart just like our former one, or we could just say this is over 1, so I got to multiply by 7 times 7, or because that would be the common denominator, or just by the inverse, whatever you want to say. And then you would get 6c minus t equals 7b. And then to get c by itself, you would add t. And make sure you remember that these are not like terms, so you just tack it on the back. Then you would just divide by 6. So this would be your final answer. And then for this one, if you wanted to do the multiplicative inverse, you could. But what I would probably do is I would just do our rules that I've been telling y'all about, because it just makes life so much easier. Now this can also be referred to as 3m over 5. And that's because if this is m over 1, if I multiply, I get this same thing. But just note this and this are the same. Okay, so that'd be a over 1 equals b over 1. Well, what is the common denominator? 5. So multiply, go ahead, cancel. So 3m plus 5a equals 5b. And now I just want m by itself, so I can move over 5a, and you would just minus it for both sides. You can't combine. And then you would just divide by 3. So m equals 5b minus 5a all over 3. Okay? And this is some more. Don't let the pi confuse you. This pi right here, that would still work. So here to solve for y, you would actually add 4x to each side. And then you can divide by multiple families, like we called it. So that would actually be the answer for that one. And the rest are pretty much going to work the same. Let me see if I have a funner one on here. No, I don't. So, let's see. Let's say that I'm going to give you one like we did in 8th grade. In 8th grade, I would have said ABC minus DEF equals G. And let's solve for E. So we did that in 8th grade. So if we highlight our E, just notice that we need to move over our friends first. Who are all of our friends? This term, right? Because they're not multiplied. So instead of positive ABC, we're going to minus ABC. And we get negative DEF equals G minus ABC. And then from here, once again, we want E by itself. So we're going to divide because these two terms are multiplied. And when you're dividing, it looks weird, but you can do them at the same time. And then this would be your final answer. All over negative DF. Now we did talk about in class how sometimes they don't like having negatives on the bottom. So if you, just like our other ones, how else can we rewrite it? Well, instead of putting the negative on the bottom, they would just distribute the negative to the top. So that would actually be the same as E equals negative G plus ABC over DF. Or they could even say, I don't like the fact that negative G is at the beginning of the problem. So I'm going to say ABC minus G over DF. All three of these are the same answers. You just have to remember that because the EOC multiple choice could be either way. Now if it is a short answer problem or a constructed response, then you could type in your answer anyway and you would get credit. But you just really have to be able to look and see, okay, what else can I do for this problem? Now there's more problems that you can try, and I tell you what, if you want, you can also create your own problems like this because we did many like that in class. So it's whatever you want to do, and I'm going to leave you with one more problem and then we're done with this video. But let's say I had A over B plus CD equals H. And let's say I want to solve for A. Just do your fraction rules again. Alright, this is all over 1. This is over 1. What's the common denominator? B. So multiply each piece by B. That's going to cancel. So you're going to have A plus. Now whenever you go to write this though, they normally like it to be in alphabetical order. So B, C, D equals B, H. And then what would you do just to get rid of it? Just move over B, C, D. So your final answer would be BH minus BCD. Okay? And that should actually take you to what we did the first 2 weeks in school. And that's about it. If you have any questions, you can see me before school, or you can create your own problems. And if you want, you can send your problems just to see if you did them correctly. You can send them to my email address. This is it. Which is the school web address, and then just put student email or parent email in the subject line, and that way I can just check your answers. Alright? Okay, thank you so much for watching.